What is up, YouTube? Today I'm going to be going over range sum of BST. Facebook likes to ask this question. It just has to do with binary search trees. I started a Slack channel where I post problems every day. There's a link in the description if you guys want to join. Lastly, subscribe to the channel if you haven't already. I'll be posting videos every weekday, and I'll see you guys soon. Alright, so the description reads, given the root node of a binary search tree, return the sum of values of all nodes with value between L and R inclusive. So that means greater than or equal to, less than or equal to. So it can be L or R, the value. Binary search tree is guaranteed to have unique values. So let me open, sorry, I should have had this open. So if we create a binary search tree from this example, we have 10, 5, 15, so it just goes from left to right down. So we would include 10, 7, and 15, which would equal 32. So how would we do this? Well, first we want to, if root equals null, this is just our base case, return 0, and then we want to create the sum. Make sure that, there we go. And if so, this is where we're going to check if the value is within the range. So if value is greater than or equal to L, so it has to be greater than L, think of L as lower, and root.val is less than or equal to R, then sum plus or equal the root.val. And so if we go back to the whiteboard, so we added the 10, and if 10 is less or root.val, we want to see if it's greater than L, then there could possibly be other nodes to the left of the root, so down here, that are also greater than L. So we want to check. In this case, 5 actually isn't, so we would then check, since it isn't, we would check if it's less than R, and check if it is, it's we would call it the right dot or root dot right. So let me just show you guys in the code. So if root dot val is greater than L, that means there's possibly nodes to the left. So we want to add it to the sum. This is a recursive call, but we need to add it because we reset the sum every time. So it's going to recursively on the stack add it to the sum. So we just call range sum bst root dot left and just pass in L and R. So in this instance, it's actually it's not in the value, and 5 is not greater than L. So the other case is if root.val is less than R. If it's less than R, that means there might be, it's still in the, possibly in the range, there might be some to the right of it. So let's do the same thing. Oops. And then we just want to return sum. And so what this will do is it'll go through. Let me see if I can get, there we go. So we'll call 10, it'll add it to the sum, it'll check to see that the root.val is greater than L, so it'll call add sum root.left. Well, this one is not in the range, and it is not greater than L, but is less than right, so it'll call this and check the right root.right, so we end up at 7, and 7 is in the range, so we add that, and then basically it ends up returning the sum because it's not greater than L or less than R. So we go up the stack back to 10, it checks 15, and basically returns our total sum. So that's how it recursively goes through the stack. So let me just submit this, and it works. So this is O of n runtime, and O of h space complexity, because we have the recursive stack we have to count for. It's the height of the tree. So there you have it. If you guys like this video, hit that like button, and I'll see you guys in the next video.